is locked and we are good to send that command. We have 31 minutes and 32 seconds for our support. Go for status buffer dump.
What you're looking at with a telescope, of course, is the light from billions of light years away. So the further you look, the more you're going back towards the Big Bang and understanding how the universe was formed.
The Webb telescope will be groundbreaking because it has capabilities that are different than the Hubble Space Telescope.
We have equipment that is so much more powerful than anything we've ever had before that it's almost impossible to tell what we will discover.
Hubble's accomplishments include something called the deep fields. Looking out into space and collecting light, sometimes for many days, these deep fields have revealed visually to us a universe absolutely teeming with galaxies, hundreds of billions of galaxies.
One of the neat things about the ultra deep field, and one of the things that made it so unique was how long it took us to take that image. There's an exposure time that's expressed, I think it's 11.2 days. There's a very, very long exposure time. But probably what's more important is how many orbits it took us to do that. 400 orbits of Hubble data to take that image. You only get 15 orbits a day. To take 400 orbits and say, we're going to observe this one spot in the sky for 400 orbits. And the really unique thing about that was they picked a spot where there wasn't anything. They looked and they said, there's absolutely nothing here. And they said, you want to spend 400 Hubble orbits looking at nothing? And they said, yes, because we want to see what it can see. And I think the results from the science, I mean, it was amazing. What they saw was spectacular.
Hubble spent 2 weeks taking pictures of empty places in the sky, and they saw they weren't empty at all. They were thousands and thousands of galaxies.
We were amazed how many galaxies we've found, and we continue to go back to that portion of the sky to increase that visibility.
The Hubble Space Telescope is an outstanding time machine. It's incredibly important for our studies with the Hubble Space Telescope to realize that when we're looking at a galaxy, we're seeing it as it was millions of years ago, sometimes billions of years ago. It's taken that long for the light to get to us.
What you're looking at with a telescope, of course, is the light from billions of light years away. So the further you look, the more you're going back towards the Big Bang and understanding how the universe was formed.
What Hubble has revealed is that the universe has in fact changed over these billions of years of time. The early galaxies, the very distant ones as we see them, are simple. Sometimes they're messy looking, they're small, they haven't had time yet to form that grand spiral structure. Over time, we see galaxies actually merging with other galaxies and growing bigger and bigger, and those mergers can look like train wrecks in our Hubble images.
These very, very deep exposures that Hubble has been able to take, we have seen right to the edge of the universe, 13.5 billion years. When Hubble was first designed and envisioned, it was never thought it could actually see that far out. But because of the advances in the instruments that we've been able to put up on the telescope, and also the cleverness of the scientists, they've come up with very interesting observing scenarios, doing these really deep exposures where we just sit there for orbit after orbit after orbit, gathering the photons. We've been able to push Hubble out very, very far.
As Hubble looks out into these fields of galaxies, we sometimes see clusters of galaxies. These are galaxies that are held nearby each other by their mutual gravity. These clusters are massive conglomerations. There's so much mass that they have an actual observable impact on space-time itself. Einstein predicted that mass distorts space, but we didn't realize we could actually see the effects of that. But with Hubble, we have been able to see distortions in space around clusters of galaxies The way we see that is when light from a background galaxy travels through that cluster of galaxies or around it due to this gravitational lensing effect. The lensing also magnifies that background galaxy, so if we look in some of these distorted arcs, we can see more detail than we would ever have been able to see without gravitational lensing, nature's boost.
There are observations where we're explicitly looking for the lensing, and they're getting science out of that just otherwise would just not be doable. Hubble has really taken that to the next level. It's doing large amounts of astrophysics that it's just never been able to do before.
Some of what we're doing with Hubble is to prepare for the new James Webb Telescope, which we anticipate launching in 2021, which will be able to see farther into the infrared part of the electromagnetic spectrum. That enables us to see some galaxies that are difficult for Hubble to see because they're so far away that their light is traveling through us through expanding space and gets stretched out into redder wavelengths, often far into the infrared part of the spectrum, even sometimes beyond what Hubble is able to detect well. The Webb telescope will give us more information about some of those very distant galaxies.
The James Webb Space Telescope is the follow-on telescope after the great Hubble telescope. It extends the discoveries of Hubble into the infrared spectrum region. We think that the first objects that grew out of the Big Bang material probably happened in about 100 million years after the start. And we think the Webb telescope can pick them up. They're rare, they're hard to find, but they should be there. The farthest we've been able to see with the Hubble telescope goes back about 800 million years after the expansion began. So we think we get much closer to the first objects with the Webb telescope.
Hubble gives information that the Webb telescope cannot give about visible and ultraviolet emission from things in the universe. And when we have all that information coming in at the same time, it's like a banquet of scientific return.
Now when we get the complete picture of every wavelength you can possibly see from ultraviolet to infrared, we hope to have the story of the growth of the first galaxies from the primordial material. So that will be a huge accomplishment that depends on both pieces of equipment, the Hubble telescope and the James Webb telescope working together.
So astronomers are very excited about this probability that we'll have both the Hubble Space Telescope and the Webb telescope operating at the same time for quite a few years. That will give us an abundance of new understanding about the universe. And already right now with Hubble, we're doing preparatory observations for the Webb telescope. We're using Hubble to do things, for example, like surveying distant galaxies to find out which ones would be prime targets for the Webb telescope. In fact, scientists around the world are proposing observations with Hubble right now specifically to help us learn information that will be useful for making the best use of the Webb telescope as soon as it's launched and gets going in its science observations.
I think the Hubble telescope has been the most productive science instrument ever built. In astronomy, there's what we knew before Hubble, and now there's what we know after Hubble. They're so different. Of course, Hubble has now had a life of 30 years, so it's had a long time to make this revolution happen. So it's not all at once. It's a gradual revolution, but it's still a huge revolution. Technology has changed dramatically over the 30 years of life of the Hubble telescope. So you couldn't even have imagined when the Hubble was launched that we would have the wonderful cameras and spectrometers that we fly today. We figured out how to send astronauts, we trained the astronauts, we figured out what instruments could be put in, we figured out how to repair everything that went wrong on the Hubble, and it's still alive. It's today, 30 years after launch. And I am so thrilled to say that our people were able to do that. That's the operations team that makes this possible. It's a miracle as far as I'm concerned, because it didn't have to be that way, but they made it happen.